Hello, I'm Graham Taylor. I'm a fourth year Space Systems Engineering student at the University of Southampton, and I'm a member of Project SHARP. Project SHARP stands for Southampton High Altitude Reusable Platform. We have a platform that will be attached to a large helium balloon that will then float up to the edge of space, approximately 30 kilometers. That's about 3 times as high as a normal jet plane goes, twice as high as Concorde goes. And the next thing above our balloon when it flies will be satellites in the International Space Station. So the main aim of Project SHARP is to develop a platform that is easily accessible for academics and the research community, that allows them to gain cheap and effective access to the high altitude environment and the edge of space. We hope to be able to develop a platform that allow you to take any payload of a reasonable size up to the high altitude environment, collect data, and then return this payload back to the Earth with a reasonable certainty so that you can collect it afterwards.
Part of the group is testing using cameras attached to the balloon just so we can get some shots from high up. That's not connected via our platform at all. Currently our programming team trying to see if the transmitting code will work. We're connecting that to our electronics module as we speak, and hopefully we should get our first transmission through the module. At which point, if we can get the transmitter working, we should then be able to launch the platform, get some good GPS data back, some altitude data, temperature data down from the balloon. But that's an ongoing process.
So there's 2 main aspects of the project. There's the plug and play interface, which is really allows anyone without any experience of high altitude ballooning to get involved and do some research in this field. But that's one real key kind of aspect of our project. The others is we want to try and guarantee some certainty of getting the balloon back. When flying balloons, they're not allowed to be controlled in any way. That's Civil Aviation Authority regulations. So they're completely free flying, they're subject to the whims of the wind, the jet stream in particular. There's also various uncertainties with regards to the burst altitude of the balloon. It's quite hard to be accurate with filling the balloon with the right amount of helium. There's quite a complex system of interactions as to when the latex balloon actually bursts. And unless you know that with some reasonable accuracy, you won't know where it's going to land. So with our system, we have a GPS tracker that continuously provides us an update on location and feeds that back down to us on the ground. We can then use that information to pass into a weather simulation to continuously update our predicted landing sites, and then continuously move towards that landing site so we're there as soon as possible after it lands.
As you get closer to the balloon, and as the balloon starts dropping down quite rapidly, you get to about 2 kilometers altitude, 1 kilometer, and you lose contact with the balloon.
The GPS is good, but it only gives it down to about kind of 50 or 100 meters. So you have to go and start wandering around farmers' fields in the hope that you'll find it. So nice bright colours is order of the day.
So anything that can help point out where it is.
In the event that we feel our balloon is going to be going somewhere where it shouldn't be going, be that over the sea or over a heavily populated area, we have a system where we can send the command to the balloon to cut away to the payload, to cut away from the balloon, enabling it to fall away, and then if it is going somewhere dangerous, we can prevent that.
So at the bottom here we've got the pyrotechnic cut down controlling module. It's connected through here to the pyrotechnic cut down itself, and here to the gadgeteer module.
So there's a small pyrotechnic device on the string between the parachute and the balloon. When we fire that, it just severs that string and we just fall away.
That couldn't have been better timed.